Hi, welcome to Computing Foundations, a channel for beginners who want to learn about programming, computers, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. We're continuing our process of learning the C programming language, and today's topic is strings. So, what is a string? Well, we've seen in some of the example programs that we've looked at before, code that looks something like what I'm showing you here. We'll define a variable, here an integer called score, and then we'll call the function printf, and we'll do this thing where we put double quotation marks, and then inside of it we put a sequence of letters and spaces and symbols, and then finally a variable which will be filling in the value for this %i. And we've been using this without asking a lot of questions about, well, what is this thing between double quotes? You might have also noticed that we've defined a lot of different kinds of variables, but we've never defined a variable type that would hold something like a sentence or a phrase. So if I wanted to store Team A score, the phrase or the sentence, into a variable, we haven't seen any examples or any tools that would allow us to do that. The only types that we've seen before are the integer, the floating point number or rational number, and the individual character, which is just sort of one of these letters. So how do we represent strings in the C language? This is something really common that we want to work with in programs. If you think about a web browser or a word processing application like Microsoft Word or Google Docs, the operation of working on collections of words and strings is something that we do a lot with computers. All right, arrays to the rescue. We've been learning about arrays in some of our past videos, and we're going to see today how arrays can be used to represent strings. So in a really simple way of thinking about this, I certainly could have created, if I wanted to store my name, 4 individual variables, and each variable could hold one letter of my name. Well, this looks a lot like what we were complaining about when we started talking about arrays. We were complaining about the explosion of variables and how you don't want to have a variable for every single related thing that you might have, like the scores of a baseball game for 9 innings. I don't want to have to write 9 integers. Well, similarly here, I could say, well, hey, let's do an array of characters, and we can store my name in an array of characters where each element represents one letter of my name. All right, that sounds pretty good. So we might do something like this. Car name array equals, and we would initialize the array to JOSH. Looks pretty good. That's how I could define a phrase and store it in a sequence of memory locations. But if you wanted to write a function that would take this name and print it to the screen, so I'm declaring a pretend function called print name, and I'm going to pass it my character array, which remember is just passed into the function as a character pointer. Well, I would really struggle to write this function because I'd need to know, well, how long is this name that you've passed into the function? I can't tell how long it is by just looking at the pointer to the name. I can't call size of on the pointer that gets passed into this function. So what would I have to do? Well, I would have to pass in to the function something like integer size, and every time I wanted to call a function or operate on my character array, I would need to let the function or whoever I was giving the array to, I would have to let them know how long is the string so they could loop through and print the string out. Well, in the C language, we ended up, or the way the language implementers ended up handling strings is they created a concept called a null-terminated string. So what they mean by that is at the end of a character array that is going to represent a string, by definition, by standard in the C language, we terminate it with this special character. It's a backslash and a 0. What this \0 represents is the value 0. It represents a set of 8 bits that are all set to 0, and we call this the null character. It can't be printed to the screen. It doesn't represent anything. It's just used as a marker to identify the end of a string. So we have a method to initialize strings that's very easy. It's much easier than doing something like I've showed you here where I have to write each letter in single quotes. We can simply say, define a character array and then set it equal to a set of letters and spaces and symbols inside double quotes, double parentheses, and the compiler will understand that we want to define a string. It will copy these letters and spaces into the memory location called name, and it will automatically add a final character that is the null terminator, the \0. It'll do this for us as a convenience. So what will ultimately end up happening is the length of this character array will be the length of the string you wrote plus one additional element to hold the \0. So this is one of the sort of tricks about character arrays or about strings that you have to understand in the C language, is they're represented simply by an array of characters, but you need to make sure you reserve a space at the end for the \0, and that way users of your array will know how to search for the end of your string. So to give you just a little bit more of a concrete example, what will happen when we initialize the name array to my name in quotation marks is memory will be reserved and initialized with my name and a final element with the null terminator. And the name variable is a pointer to the first element of this character array, just like any other array. And I can pass this character pointer around in functions, and the user of or the person, the code inside the function will know how to find the end of my string. But this isn't required. You could have defined your string like this and omitted the \0, and then the function wouldn't know how to find the end of your string. So it's very important to be aware that your strings need to be null terminated. Okay. That's how strings work. And in order to make use of strings, there's lots of things that you need to do with strings. And to support us, the standard C libraries include a library called string.h. And in this lesson's or this video's accompanying program, which is program 12, and it's titled 12-strings, I walk you through a number of examples of using this library to do common operations on strings. I'm going to walk you through a few of them very briefly here on paper. So the first one is called string compare. We use it often to take two different strings and decide whether they're equal, and if they're not equal, what alphabetical order are they in relationship to each other. So if you think about the alphabet, A, B, C, D, all the way to Z, you could think of these as sort of representing numbers. In fact, in the computer, they are represented as numbers. And we could think of A as being the smallest and Z as being the largest. So when I call string compare, the way to think about this mentally is imagine if string 1 was a number and you were subtracting from it string 2. Okay? There's 3 possibilities for the result. First of all, if we think of this as a mathematical operation, we could end up with a negative number. That would mean that string 2 was a greater value than string 1, meaning it must have occurred later in the alphabet. So when we get back a negative number, we know string 1 is before string 2 in a alphabetically ordered list. If we get 0, we know string 1 equals string 2. They must be the same string. And if we get a number greater than 0, we know that string 1 is after string 2 in an alphabetical listing. Because the only way to get a positive number would be if string 1 was a greater value than string 2, meaning it was later in the alphabet than string 2. So that's the string compare function. Next, we have a function called string length. It's real obvious. It just steps through your string looking for the null terminator, and it returns you an integer to tell you how long is your string. This is useful because sometimes the character array in which our string is stored might be larger than the string itself. I may create a character array of 100 characters, but only write into it my name, which is 4 letters. So string length gives you the numerical count of characters in your string. It does not count the final null character. Next function that's really useful is string copy. It allows us to take one string, the source string, and copy it into a destination string. Both of these are just character arrays, so we need to make sure that the destination is at least as large as the source so that there's plenty of room to copy the string into the destination. String cat. This stands for string concatenate, or put 2 strings together. So in this function, string 1 and string 2 will be smushed together into one string. And the way the function returns that string to you is it actually alters string 1 to contain string 2 at the end. That means string 1 needs to be large enough to hold all of the space, or the character array in which string 1 is stored needs to be large enough to hold itself, its string, plus string 2, and the final null terminating character. strchr, string car. This is a search function. It's used to take one string and locate inside of this string whether or not a certain character appears in the string. This is a little funny because we pass the character as an integer, but you can just think of it as a character, A, B, C, D, E, F, G, and this function will return to you a pointer to that occurrence, the first occurrence of the letter it finds in the function. So this is a way to search into a function, search into a character array, into a string, and see if you can find a specific character in that string. Another really popular function that's very similar is string, str. This function takes a string and then a second string, which is a smaller substring, and it tries to find this string inside of this string. If it finds it, it will return you a pointer to the substring that it found. Each of these functions that I've gone over with you, or most of them here, also have another sister function that starts with strn, the letter n. So there is an strn compare, an strn copy, an strn cat. This version of the function has an additional parameter that allows you to specify the length of the first array, more or less. So it allows you to say, hey, my source array that I've given you, or my destination array that I've given you, is only 100 characters long. The array is only 100 characters long. This allows the function to be a little safer. It'll never run past the end of your destination array. It will stop copying, or it'll stop concatenating, or it'll stop comparing once it's hit the number of characters that you've told it is the limit, the n number. So it's important to understand how each of these functions works. And the advice that I will give you is, if you just search online for string.h, you'll find a number of different references to these libraries online. One of my favorite references is just called c++.com. This website is actually a bunch of different references and tutorials for the C++ language. However, C is a subset of the C++ language, and in this lovely website there is a very clear description of all of the standard C libraries. One of those is the string.h library, and each function in the string.h library has a nice page that describes to you the inputs, the outputs, and exactly how the function works. As you advance in your programming, it will be important to just learn to read these library references to get the final word on how these functions operate. So rather than really tediously explaining them all to you here, I'm just giving you a brief introduction, and you can reference a official reference of the library online. Okay, the second library that's really important with strings is the standard IO library, and we've seen this library before. We use it for printf, we use it for scanf. Well, it also contains a function called getS, get a string. This function reads a string from the screen all the way until the user presses enter. So you can keep typing, and when you finally hit enter, this function will capture everything that was entered by the keyboard and store it into a character array that you passed. I just called the array buffer. Now we have to be very careful, because nothing keeps the user from continuing to type millions of characters, and perhaps your buffer doesn't have millions of elements to store all of those. So if that happens, you're going to run into errors in your program. That's why there's a separate function called fgetS. fgetS is a different version of getS, and it allows us to pass in a size. So we can say, hey, my buffer's only 100 characters, so read from the screen until you get a return. It's called a new line, until you get a new line, or until you reach the maximum size of my array. So this fgetS is a more popular and safer way to get a string from the screen. Okay, that's it for strings today. My recommendation for you is that you look at Program 12, where I've provided lots of examples of calling and using these library functions. Play around with the program, change things, run over the edge of a string buffer and see what happens. Test out the boundaries of these functions and see if you can observe behavior that you didn't expect. Because operating with strings in the C language, admittedly, is not the easiest thing in the world. It's very easy to make mistakes and to forget that your strings need to be null terminated and keep everything in order. But with practice, you can learn. So thanks for joining me today, and we'll see you in the next video.